Hi, Cliff Break from Beck Systems. I'd like to discuss the Simple IoT client model and go over a few things. So in this screencast, we're going to go give an overview and look over some of the documentation. And then we're going to look through the code of the client interface and kind of show how it's put together. And then look through a few examples of Simple IoT clients. And then discuss client lifecycle management. So why do we have clients in Simple IoT? In Simple IoT, there's generally we organize the entire configuration as a tree of nodes, and these nodes each have points that are basically fields or properties of the node, and these define this configuration basically defines the entire operation of the system. So the nodes are a declarative, static description of the system, of the system's configuration and state. But then we have to have code that takes this configuration and does stuff, and that's where the client comes in. Clients execute the logic of these nodes, whether it be a rule, a signal generator, a database, a messaging service like Twilio, a USB connection to an MCU, and so on. So this architecture where everything is a node, is stored as node endpoints, and then most of the functionality is implemented as a client, is it's fairly simple. Simple it is. These are constraints, that we store and manage our data this way. But this simplicity also gives us the flexibility. Makes this system extremely flexible. So if we go to the Simple IoT documentation, the reference guide, architecture client section, there's a diagram that kind of shows how this is put together. So most of the system is now implemented as clients. So you'll see a store, a NAT server, and then a whole bunch of clients, and that's pretty much all the system is. And again, it's very simple, but simplicity gives us flexibility. And each one of these clients basically just sits on the NATS bus, subscribes to data, and then publishes new data. So the nodes in the configuration are organized in a tree. So each one of these dots that I'm highlighting right now would be a node. And then each node can have children. And the connection between a parent and a child node is what we call an edge. And both the node and the edge can have attributes. So it's just something to keep in mind. And that comes in handy if we mirror a node in two different places in the tree. The location of it can also have properties. So a user could have permissions in one place and different permissions in another, as an example. So now let's look at some of the code that we use to implement clients. So there's a package in Simple IoT. If you go to the Go documentation, the Go package documentation, Simple IoT, and then the client, there is a lot of functions in here that are handy for when you're implementing clients. There's also an example, and the code is included here. But this code is also included in the source code as well. So let's look at it there, since it's a little bit easier to read in an editor. So let's see, let's get to the right view. Okay, so this is our is just an example. It's basically the bare minimum you need for a client. And actually, let's look at the interface first. So this is an interface that you need to supply for Simple IoT, for a Simple IoT client. So it's pretty simple. You have start and stop functions, and then you have a points function that gets called by Simple IoT when new points are generated for that node the client represents, or the client implements logic for, and also edge points for this particular instance of the client. So if any new points are generated, these points flow into these functions, and then you can take action. So let's go back to the example. So each client has a configuration, and this configuration pretty much matches what you see in the UI. And every client should have an ID and a parent, and this allows us, if points come in, we can match things up, especially if there's more than one node in the configuration. So this Go type here is what we call the client config, and it has tags, node, point, and edge point tags. So the node tags would just be the ID and parent. The point tags would match the point types in the node, and then also edge points if we have any edge points. So the second type in a client is basically a type that describes the client itself. So this first struct is just the configuration, and then this type is the actual client. And we typically store the config in the client, as well as some channels and other things we need to pass things around. The third part of a client is what we call the constructor function, and this function is called whenever Simple IoT detects a node of the type the client works with. So we might have a DB node or a user node or a rule node, and this constructor would be called whenever one of those nodes that we've registered shows up in the node tree. So this constructor gets called, and it takes all the node information, the points, and it decodes them into the configuration for this particular client. And then it passes that config to us as the config variable. And then we can set up our client however we want. Typically we store off the config, we store off the NATS connection, set up a few other things, and then that's all we need to do. And then the client manager in Simple IoT calls the start function for this client. And this start function has all the main logic of the client. This is the core or the hub of the client. And this again is a bare minimum. So these are the points and edge points functions I showed you earlier in the interface. And typically we take these points, we pass them to a channel, and then in our select statement in the start function, we take these points and we merge them with the existing config. And this merge points function uses reflection and intelligently takes a point, walks through your config, looks at the tags, and then applies the point wherever it makes sense. And you can also add additional logic in here, if there's special point types that you need to do something with. And the last function is a stop function. So that stops the client, frees all resources, and so on. So that's basically it for the client interface. And let's look at two real examples. The first one will be a database client. So if we go to the top here, if we look at these fields in the database client config, we see description, URI, org, bucket, auth token. Now, if we go back to our UI and we look at a database node, we'll see roughly the same thing: description, URL, organization, bucket, auth token. So again, what you see in the UI pretty much maps to the config, and then these point tags are the point types that we extract from the node tree. Again, here's our type that represents the client, our constructor. Start function. You'll notice this start function has some additional code in it because it's actually doing something. So in this case, we're going to subscribe to points of the parent, and any points that we receive, we're going to shove in a channel. And then down in our main select loop, we'll take these points and we'll stick them into influx. So this is a very typical client, fairly simple one. It's basically just looking for points, sticking them in influx. The second client we'll look at is a rule client. And this one is a little different in that it has multiple nodes for the configuration. So let's look at the rule in the UI. So here's our rule, and if we expand it, we'll see it has child nodes, conditions, and actions. So this is an example where one client uses multiple nodes to define its configuration. If we go back to the code, we'll see that this configuration type has several arrays in it, and these correspond to the child nodes. The conditions and the actions would be actually child nodes, and Simple IoT has utility functions that can take a set of a node and its child nodes and just automatically decode it into this data type. So again, we see a new tag here called child, and that tells the decode logic that we want to look for data for this in a child node. And beyond that, things are pretty much the same. If we look down through here, I don't think there's too much that's... Again, if we get new points, Simple IoT will again set up all the subscriptions we need for the node points for that particular node and the child nodes. It'll send them to us. We can call this merge points function, and merge points uses reflection and again walks through your config and applies the point changes wherever they're needed. Okay, the last thing we want to talk about is lifecycle. And lifecycle is one of the more difficult problems in programming, especially with a dynamic system like an IoT system where things are always changing, they're coming and going, you're going to be configuring things at runtime, and you want to be able to manage all this, without leaks or resources being locked that should be released. So we've done a lot of work in this area, and what we've settled on is what we call the start-stop pattern, where every piece of code that has lifecycle associated with it has a start function and a stop function. And the start function blocks until that client's finished, and then it returns an error. And the stop function, the only purpose of the stop function is to signal the start function to exit. And we know that the client has exited when the start function returns. So this is a very simple, but it's a very powerful, very, very clean way to manage things. And let's go back to our database example. So inside the database client stop function, we close a channel which signals the select loop in our start function to exit. So we simply break out of this loop, and then we clean up everything. In this case, we're going to clean up the influx client. So one thing you might think about, or might tend to do, is clean up the influx client in the stop function. Why not? Well, the problem with that is the stop function and the start function run in two different Go routines. So now you have a race condition. So it's best if you can manage all of anything that touches the state of the client. We do it all in this select loop, and anything that needs to get data or modify data sends it to this select loop in a channel, or sends a request via a channel, and then we mutate or access the data in this select loop, and then if necessary send it back out a channel. So that's a very clean way to manage access to the state of these clients. So I think that's it. So in summary, we've discussed why we implemented clients in Simple IoT. It gives us a consistent and flexible architecture for adding functionality to Simple IoT, and it handles a lot of the lifecycle and boilerplate code, so it's fairly easy to add a new client. And it just generally simplifies the whole architecture. So it's taken us a little while to get to this model, but it seems to be working nice, and I'm pretty pleased with how it works and the experience of adding new functionality to any system. And again, these clients can live in the Simple IoT process, or they can be an external process. So they could be written in any language. If it's external, it could be Python or C++ or whatever. But the model allows us to these clients, because we do restrict and constrain the interface. It gives us a lot of flexibility in how we implement these clients. That's it. If you have any feedback, let us know. Thanks.